we are asked to find all solutions of these trig functions. This one's in terms of degrees, this one's in terms of radians. Okay, well, the first thing we need to do is we need to isolate the trig function, meaning move everything else to the other side of the equal sign, solve for the trig function. So I'll go ahead and subtract 2 first from both sides. I have 4 cosine of 10x equals 0. Oh, that's nice. Then I'll go ahead and divide by 4, divide by 4. I have cosine of 10x is equal to 0. All right, so if you remember, this is where I like to look at the oscillating function to help me out with this. So cosine, let's also remember that usually x is between, in this case, degrees. Pi would be negative 180 and 180. It's usually between negative pi and pi. Okay, so when I'm looking at this, I want to look at the oscillating function for cosine, and I like to look at the positive and the negative side. So cosine, what I always remember about cosine is it starts at 1, oscillates, and that's where it repeats. So repeat in degrees, so that would be at 360 degrees is where the repeat is at. This is at the pi mark, so that's at the 180 degrees. Now let's look at the other side. All right, so this is at negative 180 degrees, and then this is at negative 360 degrees. Okay, and this is for cosine. So in this case, the cosine is equal to 0. Where is the cosine equal to 0? Kind of in between these intervals. So can you see the places where cosine is equal to 0? It's right here and right here. It has an output of 0. So where is it equal to 0? I'm saying where is it 0 on the y-axis? That right there is at the 90-degree place. That would usually be pi over 2. This is also the negative 90-degree place. Okay. Now, what that means is that this has those two solutions. This is equal to, as an output of 90 and negative 90. That's where this is equal to. So I'll go ahead and, I think I jumped steps a little bit right here. Let's isolate the x. So I'll do cosine inverse to both sides. So cosine inverse, that would be, I'll do my work over here. So it's called arc cosine of cosine of 10x is equal to arc cosine of the other side, which is 0. All right, those are inverses of each other, and I get 10x equals, that's the same thing as cosine inverse of 0. Cosine inverse of 0, that's what I just found right here, so I jumped the gun a little bit. We're looking for the output where cosine has the value of 0. The output of cosine is equal to 0. And that's at the two places. So this now becomes, these undo themselves on the left. I already got that. So that's 10x. And where is this cosine equal to 0 at? We said it's at 90. So this is equal to 90 degrees. And then we have that repeat idea. It repeats itself every 360 degrees. Every 360 degrees. So in 360 degrees, where n is an element of the integers. Okay, so it repeats every 360 degrees. We also have the other case. I'll go ahead and do it right here. The other case, that's this one right here, the negative 90. So I also have 10x equal to negative 90. Plus our intervals of 360 degree oscillations or rotations, however you want to look at it. And once again, n is an element of the integers. So now I just go ahead and solve for x. So I solve for x, divide by 10, divide by 10, divide by 10, and I get x equals 9 degrees plus, that's 36. I'll put n at the back, and that's a degree. That's done. Okay. Those are its intervals, and I'll do the same thing for this one. Divide by 10, divide by 10, divide by 10. X equals negative 9 plus 36 in. Those are in degrees also. Okay, so those are our two sets, and that means we have these two answers that, it'd be like that, and like that. And going the other way, like that, like that. Okay? So that's those answers. So that one is done. Find all solutions in terms of degrees between these intervals right here, basically. Okay, let's go ahead and do one in radians. All right, for the radians. Done exactly the same way. We need to get the trig function by itself first. So I'll go ahead and minus 65 to both sides. Minus 65. I now have negative 15 is equal to 25 cosine of pi t. And divide by 25. Divide by 25. And that's negative 5 goes into 15 3 times, 5 goes into 25 5 times. All right, and now I have cosine by itself. Okay, we have to get cosine by itself so we can do the inverse operation to get rid of cosine. So the opposite of cosine is arc cosine. I do that to both sides. I'm going to go ahead and this is the step here where you do it to both sides. I'm just going to go ahead and show. I've taken that away with the arc idea, so it's cosine inverse of negative 3 over 5. That's equal to pi over t. All right. And it is time to do that same idea. So this is telling me I have an output of negative 3/5 for my cosine function. All right, so here's my cosine function again. I want to make sure I have enough room. Well, I don't want to do it on Gilbert. All right, fine. I'll do it right here. All right, so remember, where did I say to start at cosine? I start at 1. And I like to do 1 repeat on each side. All right, so this is the cosine function. That's at 1, that's at negative 1. And then finally we're in radians. That's how I understand this a little bit easier. So that's at pi, that's at 2 pi, negative pi, negative 2 pi. And then if you wanted to, I like marking all the points where they cross or the maximums, minimums, but this is fine for now. Okay, so we're asked for an output of negative 3/5. Do you know where that would land on this graph? Well, where's negative 3/5 at? As an output, that's a y. So negative 3/5 is down there. That means our solutions, and once again, we're talking about x's between negative pi and pi. Okay. That's usually our normal restrictions on here. We focus on that interval and then we can repeat it there on. So in this case, where's our answers at? Right there, right there. So those are the solutions that cosine would have as an inverse, an output. So that means what is that x and what is that x? Well, let's type it in on the calculator, see what the calculator says. You remember what I said to do on your calculator? As soon as you open it up, what's the first thing I should do? Make sure it is in radian mode. So as soon as I open the calculator, I turn it on. Sure enough, it's in degree right now. Shift, setup. I want to be in radian mode. Now I'm in radian mode. And I am doing cosine inverse, shift cosine, that's cosine inverse of negative 3 divided by 5 in parentheses. That gives me, all right. So this right here is 2.214 dot dot dot. That's equal to pi over t. So I plugged this into my calculator, that's what I got. Well, what does that mean in terms of what we have here in the kind of this context? Well, what that means is, and notice, pi is 3.14, so it's nice to kind of get a handle on what's going on here. So this 2.214, that's this answer right there. That's that 2.214. Well, what do you think that answer is? Notice it's symmetrical on both sides, off of the y-axis. It's symmetrical. So that means this answer right here is negative 2.214 dot dot dot. All right. The one thing that we always need to we need to consider, since we were asked for all solutions, is that idea of the oscillating and repeating function. So these two answers get repeated this way. These two answers get repeated this way, every 2 pi in this case. So what I do is, this is kind of what I had, the 2.214 dot dot dot, and then it repeats every 2 pi. So plus in 2 pi. And that was equal to the pi t. To the pi t. That's that one. I don't know if I'll have enough room, I'll try. The other one is negative 2.214 dot 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 plus n 2 pi is equal to pi times t. Okay, and we solve for t, so divide by pi. Divide by pi. Every term gets divided by pi. What you do to one side, you do to the other side. Every term gets divided by it. All right. I'll just go ahead and simplify one at a time. So this answer is t is equal to 2.14 divided by pi is 0.704 dot dot dot, and then these pi's cancel, plus 2n. All right, so there's one solution. The other solution, done in the same way, divide by pi. What you do to one side, you do the other side. I like doing it term by term, that's easier. This is exactly the same thing as this one, just negative, so that's negative 0.704 dot 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 plus our 2n. That equals t. And there's our second solution. So that gives us all the repeating solutions on both sides.